All right, picking back up, this is still section 2.1. So the next thing we want to talk about is the relative and absolute maxima and minima. So a relative maximum point, sorry, and I made kind of a boo-boo when I typed this up. A relative maximum point is a point at which the graph changes from positive slope to negative slope. So that might sound crazy, but I'll show you in a picture. So positive slope to negative slope. So we talked before about what a relative maximum looks like on this. So like maybe one right there at -5. So at that point, right before it, the slope is positive, and then right after it, the slope is negative. So that's a way that we would know if something's a maximum is if the slope goes from positive to negative. And I would hope at this moment that you would think slope. Slope reminds me of a derivative, because we will get into that. So a relative maximum is a point that is the max in its area. So nearby, like close around it, it's the maximum. Similarly, a relative minimum is a point at which the graph changes from negative slope to positive slope. So a minimum over here at 3, notice beforehand the slope is negative, and then it's 0, and then the slope becomes positive. And a relative minimum point is just the minimum in its area, nearby. It doesn't have to be the lowest point of all time, just has to be low for what's around it. Whenever we talk about a relative maximum or a relative minimum, we'll always use the x value. So like we would write, if I wanted to list all the minimums here, I'd write x equals -3. So even though at x equals -3, the relative minimum is like a little bit more than -1, we're just going to write the x value. So -3, 3, and 7. This will be a little bit different when we talk about like the absolute maximum, but let's try a problem or two. Just give it a shot. Where does f of x have a relative maxima? X equals, so again, we're using the x values. And for maximums, there seems to be one here, 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 and here, the little peaks. And instead of looking how high they go, I just want to look at where they happen. And that's at x equals -5, 0, 5, that's a 0, and 9. And then where it has a minima, that happens here, here, and here. So let's see, that's -3, and 3, and 7. It's pretty cool. All right, so next big idea is the absolute, so the actual maximum value. And it's the largest y value that the function attains on its domain. So the y-axis is here. So it's the highest that the y coordinates ever get to, which happens at like 6.2. So notice when I'm talking about the maximum, the actual maximum, I do use the y value because there is only one maximum value, or 0, but it's unique. The minimum value is the smallest y value that the function attains on its domain. So this graph doesn't have an absolute minimum because there isn't like, you can pick any number you want. I can find a smaller one. There's no like limit to how negative this gets. So there's no minimum for this one. But this is important. When we talk about the maximum value or the minimum value, we always write it with the y value, sort of like y equals highest or lowest point. Highest or lowest y value. Cool. So in this case, does f of x have an absolute maximum? And does it have a minimum? If so, what is it? So we kind of already answered that, but let's go look. So the highest y value that this gets to is 6.2. And then, so I'd write that y equals 6.2. But there is no minimum value because the function keeps going negative in either direction. So it does have a maximum. That's y equals 6.2. It does not have a minimum. Cool. So yeah, we'll pause here and feel free to ask questions.